Hi everyone, welcome back. Lastly, we learned the basic usage of this HOGDescriptor, and today we are gonna learn about the most important function of this class, which is detectMultiScale function. And actually, I want to talk about the details of the parameters in the code part, so we can directly switch to the code part. This was the code from the previous video, and we can continue on this one. There is already a detectMultiScale function here, and I already have two images, which is we can continue on this. There are some pedestrians in here, so we are also using the pedestrian example of the HOGDescriptor, so we can understand the concept, the parameters, how we can use them in our example. Okay. Basically in here the detectMultiScale is just used with the default parameters, which is, if I put a comma here, you can see the default parameters of each parameter here. Okay. Actually, if we can also run the code here, what it looks like with default values, you see there are many wrong detection, wrong people detection in here. Also you see there are some missing rectangles. Similarly, in the, I think in the second example, second image, also we see some wrong parts. At least this one is wrong. So we can continue with the first image, and here basically, first of all, you are giving just your input image. It can be in the BGR image, I mean 3-channel image, or grayscale image. It doesn't matter. I think we can also check here. Yeah, here you can give 1-channel or 3-channel images as input. Also the second one, you need to get the rectangles, which is it's gonna give you the detected rectangles with this output, and you can use them by drawing, which is in the example also we are drawing the rectangles via on here. But this is the important parameters are starting after this, which is detected weights. What this means, for each detected rectangle, it's giving you the accuracy weight. What I mean is, maybe if I put a breakpoint here, and if we run in the debug mode, okay, just continue a little bit. Okay, it comes here somehow. Anyway, okay, now it comes here. Okay, here we see the detected weights. In here you see there are 9 detected rectangles. Also here 9 here is the 9 detected rectangles, and here their accuracies. For each rectangle detected, it's giving you an accuracy value. For example, the lowest one, at least you see 0.3, which is not really accurate comparing to the others. So these detected weights are the ones which is given for each rectangle, detected rectangle. So you, by using these, you can filter your results. Okay, for example, there are a couple of them is above 1, and just continue and see the image before filtering. Here there are some missing, here missing. So maybe we can just since the items between detected rectangles and weights, they are matching each other, so we can directly use here inside this loop, which is for detected weights, and just check each value. If they are bigger than 1, maybe 1 can be better, then let's in that case just draw my rectangles. Let's see how it's filtering. So at least these are gone, one missing part here gone, so mostly it's detecting fine. Here, so it's getting more better. Even we do not use the rest of the parameters, we are using them with default, but this still works fine for now. Okay, this was the first one we are talking about. Let's eliminate this and just continue with the other parameters, which is threshold. This is also detected weights. In the output you can filter, but in the process you can filter by this, using this hit threshold parameter. So this is default 0, which is giving all the possibilities to you. Let's make it 1 and see how it looks like. Okay, now also it's filtering. So you increase the process threshold, and it's eliminated even some correct cases. It's just detecting is if the pedestrians are really pedestrians. So this is the correction parameter. I'm not calling this one directly accuracy parameter, but this is the correction parameter. I can make this default again, so we can understand the usage of the others. So this win stride, which is the step size, which is the kernel is traveling the image, visiting each cells according to this size. So putting this smaller is gonna increase your accuracy. Giving this high values is gonna decrease your accuracy. So default it is 0 to 0, so it's accurate. But if we increase this to 16 to 16, maybe we can get worse results before. At least, yeah, I can say this is not really good. So this is about increasing this is gonna increase your speed, but it's gonna decrease your accuracy. So we can keep it default and we can continue with the next parameter so we can understand this padding. In our images we do not have some pedestrians in the edge of our images, so all is inside the image. So yeah, for our case this is not useful, but if in your case if you have some pedestrians which is needed to be detected, which is important for you in the edge size of your screen, edge size of your scope, then you need to increase this padding also. Currently, since I don't have any, so I will keep it also as it is. And this scale is also totally accuracy parameter. Decreasing this is gonna increase your accuracy but decrease your speed, and increasing this scale is gonna decrease your accuracy but increase your speed. The current is 1.05. also this is similar to the hard cascade parameter. Also you can check that video, and there we talk detailedly. This is totally similar logic that is in here. Also if we decrease this, now we expect at least it's gonna calculate detailedly, but decreasing this looks like it's gonna increase the accuracy, but at the same time it's finding many wrong results. For example, these windows, it thinks these are the pedestrians. So this accuracy, then we can think what kind of increasing accuracy is. Maybe you can check, he tries to find all the pedestrians, so he's checking really detail, and even if not really sure, it's giving you some results. Maybe this can be a pedestrian. In that case you need to use other parameters. For example, if you make it 1 maybe, or you need to play with others. For example, you see, right, maybe the to understand this before, if you remember, this one is not detecting, I think, if this is 0105, which is default one, you see, right, before this was not detected, but now by decreasing this, which is gonna increase accuracy, now it's detecting. So it's giving more rectangles even they are wrong, but by decreasing this you are getting the possibilities, you are increasing the possible rectangles which can be maybe a pedestrian. So you are giving to the filter, then by filtering them you understood the concept, I think. Just decrease this, it's gonna give you more options. Just filter those options and get more accurate results. This is the concept. Okay, just keep this also. Also let's make it 0. Then group threshold, this is about this is also similar to the hard cascade, one of the hard cascade parameter. This is maybe just keep it 2 and continue. For each detected pedestrians, you only see here one rectangle, for example, but actually in the background it detects around here, around this center, it detects maybe, let's say, 10 or 20 rectangles. Then it's deciding, okay, there are many rectangles detected here, there are many data we have that can be a pedestrian here. So as soon as the rectangle number is increasing around the center, around the region, then you are more sure about there is a pedestrian here. So this is deciding the threshold, which is the number of the rectangle detected around the center, around the region. So defaultly too, if you increase this, it's gonna tell minimum I want a 10 rectangle. For example, here already detected 10 or more rectangles around here. So now I can say this is a pedestrian. You are just telling to the background like this. So if you increase here more, 20, you are wanna be more sure, so there's only one left here. These are, it means these detected before between 10 and 20, between 20 and 10 rectangle detected around this pedestrian before. Okay, just keep it 2 again. Also, if you make it 0, there I believe there's gonna be many, yeah, you see there's many wrong rectangle around, so we are making it 2 current. Then the next is mean shift grouping. This is currently false. Let's make it true, and I think we are not gonna see a difference for this image because I'm gonna explain. You will just see this. If you make it false, yes, but we can understand this more easily in with the other image. Maybe if we switch to 2 and let's see how it looks like before false, before make it true. So here there is overlapping rectangles, right? This detected rectangles is overlapped with here, and this is overlapped with this and overlapped with this. If I make here true, I'm telling to the function, I'm telling to the background, do not give me the overlapping. If 2 rectangles is overlapping, just eliminate them. You see now there is no rectangle here because we do not wanna overlapping rectangle here. This parameter also working in that way. So basically in this video I just wanted to simply talk about these parameters, and I think I'm clear and they are easy to understand, but they are important. And I'm done for this video. See you in the next videos.